A couple more implicit differentiation examples. So you have this and you're like, yeah, I got this now. I know how to do this implicit differentiation, so let's just do it. Okay, so x cubed becomes 3x squared. And then we go here and you're like, yeah, that's just like 2 times y prime, right? No. Recognize that this is a product rule. And you know, especially in AP calculus, well, in all calculus, you very rarely see one of these rules in isolation. Very, very common for you to see on the AP test a quotient rule and a product rule and a chain rule all mixed up in one. So here we're trying to do implicit differentiation, and we got to do a product rule inside of it. So we're going to take this one, and we're going to find the derivative of this. So we can just split it. The 2 can go with either one. So we can say that f of x is 2x. We'll make our little box. F of x is 2x, therefore f prime is 2. G of x is y, and y prime is the derivative. So we do fig. You know what? I am going to keep the negative with the 2 so that we don't forget about that, because otherwise we would have forgotten about it. So I'm just going to change that to plus negative 2. So I'm going to have a plus there. And then we're going to have plus negative 2y plus negative 2xy prime. Yep. And now we have to keep differentiating the rest of it. Plus 3y squared y prime, and don't forget the other side, plus 5, or equals 5. All right. Now we got to get that y prime all by itself. So I have 3x squared minus 2y minus 2xy prime plus 3y squared y prime equals 5. Now this one's not as easy because there's 2 things that have a y prime in them, okay? So I'm going to make that a different color so we remember that's what we're trying to get alone, okay? So let's get everything else on the other side. So I have negative 2x y prime plus 3y squared y prime equals 5 minus 3x squared plus 2y. All right, and then how do I get that y prime by itself? Well, I just need to reverse the distributive property, bring this outside the parentheses. So I bring my y prime outside, and what do I have left over? I have negative 2x plus 3y squared equals 5 minus 3x squared plus 2y. And now I can get my y prime all by itself by just dividing by negative 2x plus 3y squared, negative 2x plus 3y squared, and I think I can just barely fit it in here. So I have y prime equals this whole mess, 5 minus 3x squared plus 2y over negative 2x plus 3y squared. That is your final derivative. All right, let's try one more. Go ahead and clear out all of our... Okay, here we have another implicit function. We can't get y all by itself. We're going to have to find the second derivative in terms of y. We got this. It's not that bad. All right, so we differentiate. So the first thing we do is take the derivative of everything. So we have 2x plus 2y y prime equals 0, because the derivative of a constant. I'm going to have a stamp made. What is the derivative of a constant? 0. Okay, so we get y prime by itself. So I have y prime equals negative 2x over 2y, because I subtracted 2x first and then I divided by y. And then the 2's cancel out, so I get y prime equals negative x over y. Perfect. That's the first derivative. Now I need to find the second derivative. So let's rewrite my first derivative in terms of exponents. because we know that we need to do that. Now let's take the derivative of both sides. Okay, what's the derivative of a derivative? Well, the derivative of a derivative is the second derivative, so the derivative of that side is y double prime. And then I've got to take the derivative of this side now. We've got a product. If we had left it as a quotient, we could have used the quotient rule as well. So, up to you, whichever one you like better. We're going to use the product rule, so let's go ahead and go over here. F of x is negative x, so the derivative is negative 1. G of x is y to the negative 1, so the derivative is negative y to the negative 2 times y prime. Yeah, it is. All right, so then I can just put that, I can do fig plus gif, fig plus gif. So I have negative y to the negative 1 plus negative x times negative y to the negative 2 times y prime. Ooh, that's ugly. All right, so we've got y double prime equals negative y to the negative 1. And those negatives cancel out, so we have plus x y to the negative 2 y prime. Ooh, hang on. And it says in terms of y, but we still have a y prime in here, so we've got to get rid of that y prime, right? But we know what y prime is, don't we? Up here we told ourselves y prime was negative x divided by y. So I can come back down here and I can say y double prime equals, and I'm going to just do negative 1 over y, so it looks a little neater, and then x over y squared, and then y prime was x, negative x over y, correct? Okay, so that equals negative 1 over y plus, we'll say minus actually, x squared over y cubed. And we could combine it. If we had done the quotient rule, it would have looked differently. In fact, let's go ahead and combine it so that we can see, we'll compare it, we'll do the quotient rule as well. So this would be y squared minus x squared over y cubed. And then you're like, can I just be done now? And you're like, and I'm like, no, because it says just in terms of y. It can't have an x in it at all. And we're like, crap, what do we do now? Well, guess what? Let's try something. Let's take a negative 1 out, and I have y squared plus x squared over y cubed. Well, have I seen y squared plus x squared somewhere before? Oh, way back here. X squared plus y squared equals 3. So I can come all the way down here and I can replace that with 3. So my final answer is y double prime equals negative 3 over y cubed. Now that was a lot of work. Let's look at it with the quotient rule just because, to see if maybe the quotient rule would have been a better option in this case, because we wouldn't have had so many negatives and it would have been more obvious which way to go. So remember, we got to the point that y prime equals negative x over y, and we need to find y double prime. So we have y double prime equals high d low, see, low d high. I said it wrong, that's why I say it this way. Low d high minus high d low, square the bottom, and away we go. Okay, so we get this as negative y plus x y prime over y squared. We're going to replace y prime with what we know y prime is, so that's negative y plus x times x, negative x over y, all over y squared. And then we can, we have negative y minus x squared over y all over y squared. And then let's get a common denominator on the top. Yeah, let's multiply top and bottom by y, actually, because we want to clear the fraction. And anytime you have a fraction inside of a fraction, a lot of times you just clear it by multiplying by the denominator. So if I multiply this entire thing by y, I get negative y squared minus x squared over y cubed. And that cleared my fraction in the top. And then I can take a negative, so this is still y double prime. Negative 1 out, and I get x squared plus y squared all over y cubed. And then that becomes negative 3 over y cubed. So there you have it. The quotient rule probably was a better option for this one because it doesn't add to all those negative exponents. Sometimes it's better, sometimes it's not. You can choose whichever one you want. But when this said in terms of y, that was the key that we had to get rid of all of the x's. If it had said in terms of x and y, or if it hadn't said anything at all, we could have just had x's and y's. But it specifically said we only want y's, so we had to get everything else out.